Hey kiddos, we are going to start Unit 9 talking about geometric series. You're going to need your Salmon series sheet available because I'll refer to that in a little bit. But let's talk about what a geometric series is. So if you remember from last week, a series is just a sum of numbers. So here I have a list of numbers with plus signs between them. Now it's a series. This happens to be a geometric series because the pattern that I see to move between terms is that we are multiplying by 2. That makes it geometric. If you are multiplying by the same value to move between terms, it's called geometric. This value that you're multiplying by is called the common ratio. And we use the letter R to talk about common ratio. Over here, this is also a geometric series, but this time what I'm multiplying by is 1/3. So yes, I know we're dividing by 3, but you got to talk about what you're multiplying by. So we're multiplying by 1/3. So I would say this is yes geometric and R equals 1/3. Okay, so that's your basic overview of geometric series. Now, if you remember, our big goal with all series from now for the next 3 weeks is to decide if they converge or if they diverge. So converge means that sum approaches a value. So as you add these things up for forever, it's going to approach a value. Diverge means it doesn't. And it's a really quick test. As soon as you decide it is yes geometric, the thing that you're multiplying, this R, if it is less than 1, it converges. If the absolute value of it is greater than or equal to 1, it diverges. And it's as simple as that. So my tips for you are to list terms. These two, the ones I started with, were fairly simple to decide that they were geometric because I already had the terms written out. So geometric series can hide inside of summation notation, and it's harder to see that they're geometric. So let's look at this one. I'm going to do a difficult one. Not difficult, but as difficult as they come. So let's make it look really scary. And we'll call this 2n, and we'll call this down here 7, and we'll call this n minus 3. Nope, n, just n. We won't make it too scary. Okay, I have to decide if it's geometric or not to know if I can use the geometric series test. And the best way to do that is to start plugging in values and listing terms. So I'm going to start when n is 1. I plug that in. -1 squared is +1, so I don't need anything. This is e squared over 7. My next term, when I plug in n is 2, I get n plus 1 makes 3, so -1 cubed is negative. And then this is e to the 4th over 7 squared. Let me do one more. I'm going to go back to positive because I'm plugging in 3. This will be e to the 6th and 7 to the 3rd. That's it. Now I got it. It is definitely geometric. To get from term to term, we are multiplying by negative e squared over 7. It's messy, but it's fine. That's the pattern. So if I want to decide if this converges or diverges, then I am looking at the absolute value of negative e squared over 7 to decide its relationship to 1. A quick little type in our calculator says that this is greater than 1, and we write, therefore, diverges. And we are done with this question. All right, but let's talk about a convergent geometric series because, again, our goal is to decide if they converge or diverge, but geometric series are special. So when you tell me that a series converges, you're telling me that when you add up all of those terms forever, that value is going to approach a certain value. With geometric series, you can find the value it approaches. You can actually find the sum. What I have on your salmon sheet, if you go look, is how to find that sum. So here's how we're going to read this thing. I'm sorry, it's not salmon in my printout. These are notes about each test. So this entire row is for geometric series test. Note, it's only for geometric series, so you need to list some terms to decide if it's geometric. These regularly pop up in exponential series because repeated multiplication is exponential, and if we're multiplying, then that could be it. And this is special, you can find the sum. So this column tells you the conditions for convergence. The absolute value of r is less than 1. And here, down here, is how you find the sum. So a is your first term. It's written here. R is your common ratio. Be careful that if it's negative, you don't take the absolute value when you're finding the sum. So 1 minus r would turn into a 1 plus if your r is negative. Over here are the conditions for divergence. You need to add with me, please, the line under the or equal to. Super sorry, I forgot that. So as we go on different days, you're going to learn a new test. Every couple of days, you'll learn a new test. I filled out geometric for you. You're going to have to do the others. So we'll have a new test. We'll put here. We'll talk about it. This column will talk about what it means to converge. This column will talk about what it means to diverge. And then you'll have a list of all of your series tests to put into your brain and in one place. All right, kids, let me know if you need anything.